Hey, listeners, before we get into the episode, I have some fantastic news. We have been working on a K-5 kindergarten through fifth grade series of numeracy problem string books and are so excited that they are, almost ready to share with the world.
Yeah, to celebrate and share their awesomeness with you, we are having a book launch webinar, and we would love to have you join us.
We are going to be live on Zoom on June 19th from 7 p.m. Central to 8:30 p.m. That's start times. 7 p.m. Central, 8 p.m. Eastern, 6 p.m. Mountain, 5 p.m. Pacific. We would love to have you June 19th. I'm going to show you what makes these books fantastic, great, super, unrivaled, and how they're like nothing else out there.
Yeah, these books are jam-packed with problem strings that will keep you busy way beyond a school year.
Interested to know more? Go to mathisfigureoutable.com/psbooklaunch. So no spaces in there. mathisfigureoutable.com/ps, that's like problem string, book launch. One more time. mathisfigureoutable.com/ps, P like Pam, S like string, book launch to read all about it and book your spot.
Y'all, it's going to be great. We'll see you there.
See you there. Hey, fellow mathers. Welcome to the podcast where math is figure-outable. I'm Pam, a former mimicker turned mather.
And I'm Kim, a reasoner who now knows how to share her thinking with others. At Math is Figure-Outable, we are on a mission to improve math teaching.
Because we know that algorithms are amazing historic achievements, but they are terrible teaching tools because mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable.
Hi.
Hey there. How's it going?
It's good. It's good.
Let's record a podcast. What do you say?
Okay, let's do it. Hey, every once in a while I like to share a review. So,
nice.
Yeah, you haven't seen this one yet, but
right.
This one, the title of it or the subject line is Mind Blown.
Oh,
which is super fun.
Nice.
And my eyes are old, so honestly, I cannot see the name of who I grabbed it from. I'm going to let you see it so you can maybe try to see the name.
Okay,
but don't read.
Right. Look, I'm just reading the name. It's I.H. Musson. I think it's initials.
Your eyes are better than mine.
IHMUSNN. Thank you for telling us your mind was blown and for the 5 stars. Appreciate that.
Okay, so let me read.
Okay.
I just finished listening to the second podcast about mean, median, mode. So this is a while back.
Okay. So we did a couple in a row, and this was the second one.
Yeah. I just have to say, I cannot believe how I didn't understand how.
You're doing great.
I just have to say, I can't believe I didn't understand how I could just view the leftovers as the fractional difference to determine mean. Not only is this more visual than to add it all up and divide, but so much easier. Pam and Kim, you continue to blow my mind with how much more figure-outable you make math for this 50-year-old math teacher.
Sweet.
Listen, I think we got several comments about that. The idea that mean is evened out.
It's not just a process. It's not just a procedure. You add them all up and divide, but you can actually think about what a mean is. And
I think that was we got several comments about that people were like, wait a second, are you serious? You can just kind of move some numbers around and make it more fair, which is lovely. I'm glad we did that episode. I'm glad people got something out of it.
And if you haven't listened to it, go check that episode out. We'll put the episode number in the show notes.
Yeah.
You can have a better sense. Data is important, as Joe Bowler's telling us, to get a data view on. We should have a data flare in our teaching, thanks to Joe Bowler and Kathy Williams and their new book that's not probably out yet. It's coming out soon. Cool.
I'm jealous.
All right. Hey, so Kim, for today, wait, what'd you say? You're jealous what?
That you got to read it.
Oh, yeah, it was super. It's been fun to get some advanced copies to endorsements. Yeah.
Very cool.
Very cool. Okay, so we've been planning to film our Building Powerful Fractions 2 workshop because we already have Building Powerful Fractions 1, which is a workshop that you can take from us right now.
Yeah.
Which I think is one of our best. It's super good. And as we've been planning to film Building Powerful Fractions 2, we've been talking a bunch about code switching.
Yeah.
And Kim, you kind of brought up the term code switching.
Oh, I don't think it was me. I think we talked about the idea, But I
Okay.
think it might have actually been Sue that
Well,
named it.
do some credit then.
Yeah.
Sue Simmons works with us. She's
Yeah.
amazing. We love
Yeah,
her.
yeah.
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 You know when you say someone's not a jack of all trades, they're a master of all trades? That's kind of
Oh,
Sue. Yeah.
absolutely.
Like if we ever need anything that we can't, there's like, "Hey, Sue."
Uh-huh.
Yeah,
She's MacGyver.
she's
That's an old person
oh,
reference.
MacGyver. That's a
That's what I'm gonna
really
start
good
calling her.
comparison.
She absolutely is.
I like it.
Yeah.
Anyway, so she brought up this idea of code switching. So Kim,
Yeah.
tell everybody, what do we mean by code switching?
Yeah. So it's the idea that, at least in this particular circumstance that we were talking about, the idea of flowing back and forth between fractions, decimals, and percents so seamlessly that you choose that you want in the moment. So, like if you're solving a problem, if you're thinking about describing information, that you choose which representation you want, because there are some times where some are better, easier, more familiar than others. It's kind of like, how if you're ever speaking to somebody who's bilingual, that, I find it fascinating that somebody who is bilingual will be having a conversation with somebody else, and you
Mhm.
can hear them flow in and out of English and Spanish or French and Spanish or whatever. And
Uh-huh.
it's beautiful to watch them as they choose words, kind of go in and out of the
It
languages.
sort of has the best meaning for the situation. And they're like, oh, it's like this word really fits here.
Yeah,
Yeah, yeah, that is really cool. And I'm a fan of languages. Really
sure. Yeah.
appreciate that reference. Yeah. So Kim, if I were to ask you a specific question, maybe we could give everybody an example
Sure.
of how you might use a different interpretation or, like you said, representation
Mhm.
of numbers. So if I were to just give you something random like 3/4 of 2/5,
Mhm.
3/4 of 2/5.
Yeah.
Tell me what's your first gut?
Like how I think
I
about it?
yeah, because I actually remember I gave you this problem. It was a few years ago, and I had some things in mind, and
Uh-huh.
everything you said was not what I had in mind. And I was like, "What?"
Oops.
Yeah, no, it was definitely on an oops. It was like oh, that's so interesting. So, what do you think about when I say 3/4 of 2/5?
Yeah, so I think the way that I picture that in my head is 75% of 4/10, 4.4. So like if you gave me that and it was a problem, I would say 75% of point 0.4.
0.4.
Yeah.
So it was 3/4 that you
Uh-huh.
turned into 75%,
Uh-huh.
and it was 2/5 that you turned
Uh-huh.
into 4/10.
Uh-huh.
And
But
so,
but I think so
uh-huh,
the reason I said point 0.4 is to give people a visual of
the way it looks.
that I do it in a decimal. Like I'm picturing a decimal, not
Oh, not a
4/10
fraction. Sure
fraction. Yeah,
enough.
yeah.
Yeah, I hadn't even thought of that. Yeah,
Yeah.
yeah, yeah. And why? Why 3/4 turning into 75% here? Why not just 3/4?
Because if I'm thinking about zero point 0.4,
Mm-hmm.
then 75% of that is easily zero point 0.3, which I would
Oh,
say maybe 3/10, but in a
because you
decimal.
like
Like 30 cents, 30 cents.
so
So
it's
if
sort of
it,
like you're thinking about 75% of 40 cents.
yeah,
And you just like you don't even think about 1/4 or 25%
no.
to get 10 and then scale it up to get 30
No,
cents.
because those fractions, I own the decimal and percent equivalencies, like
Mhm.
without thinking about it. That works well for me because I know that 2/5 is 40 cents or
Uh-huh.
40%. Like I've traveled that path in my mind so much that I don't really think about it.
Yeah, so if anybody's kind of like still grinding on those numbers a little bit, if you had 40 cents, you could think about 1/4 of 40 cents is 10 cents, 2/4 of 40 cents would be 20 cents, 3/4 of 40 cents is 30 cents. And so
Uh-huh.
you're saying that 3/4 of 2/5 is 30 cents?
Uh-huh.
And how would you write that?
Uh decimal 3.
So even though the question was fractions, 3/4 of 2/5, you would like write it as
Who
point
am I
3. I
who
mean,
am I talking to? Am I talking to somebody who is okay with the equivalencies that I'm going to write zero point 0.3?
okay,
If
okay.
it's somebody who's like you have to put it in fraction form, then I would write 3
Maybe if you're in a high school class and they're
tenths.
like, if the problem started in fractions, you have to end in
Yeah,
fractions.
yeah, yeah.
Yeah. So we might, we're kind of joking, or not joking, we're kind of chuckling about that a little bit because I think sometimes we get a little anal. Is that the word?
We get
Like a
stuck.
little
We get
picky.
stuck.
We get a little picky. If the problem was in fractions, then we have to write the answer in fractions. Okay. Is that just because it's more gradable? How many times have we talked to teachers lately? In fact, when I was golly, I think it was when I was in Hawaii, they were talking about some sort of electronic homework thing that the kids do, and they were saying how frustrated they were that when they're creating the answer keys, they feel like they have to put in so many different choices
Sure.
because otherwise it gets marked wrong when the kids
Yep.
it isn't
Oh, yeah.
actually wrong. And I think that's one thing you've complained about in the past is
Yeah.
that the kid could actually answer the question correctly, but if the teacher hasn't entered in enough of the correct different
Oh, good
anyway.
heavens. Yes. It
Yeah.
was COVID, my older son had to put in a ton, and I can't remember what he was taking at the time. Geometry, algebra 2, I don't know.
Mhm.
And it was like, holy cow, if you typed anything wrong, he had these very long answers. And I was like, I
Well,
sorry,
or
you
wrong
typed
or even
wrong.
just an extra space or,
Yeah,
like there were
absolutely.
things that
Uh-huh.
didn't even make the answer wrong. It's like we're
Yeah.
saying, we're code switching. That you
Uh-huh.
could enter in an equivalent expression, but if the
Yep.
teacher hadn't thought of that one, then eh.
Yep.
So it's kind of a bummer for everybody, right? It's a
Yep.
bummer for the kid, but it's also a bummer for teachers that are trying to enter. That was the conversation I'd had in Hawaii when they were saying, yeah, it's just so hard to try to think of all of the different kind of possibilities, and you want to
Hmm.
give the kid credit if they got it. Yeah, blah blah blah. Okay, so you're saying that when I give you a fraction problem, like 3/4 of 2/5,
Hmm.
you would turn it into percent and decimal. Like I'll just note 75% of 0.4.
Hmm.
So it's not like you went to percents or you went to decimals, you went to both. And then you left your answer as a decimal, but you could have switched it back to like 3/10
Yeah.
as a fraction.
Sure.
Cool. So I'm wondering, Kim, if I were to ask you, the exact same kind of question, like
Okay.
two-thirds of 3/4 or 2/3 of 2/5,
Yeah.
would you do the same thing?
No.
Because
Because 2/3 is funky in decimals. So yeah,
with all decimals?
that particular decimal, like I don't want to find 66.6666% of 0.75.
Okay.
Yeah.
What would you rather do?
Oh, that's a good question. What would I rather do? 2/3 of 3/4. What would I want to do? Huh. I feel like I might want to think about 3/4 of 2/3.
I wonder if that's because you're thinking about 3/4 of 2
Yeah, maybe.
thirds. So if you think about 3/4 of 2 thirds.
Yeah. But then
So
even still, like I want to go 1.75 in the numerator. People are going to love that.
1.75 thirds.
Mhm.
Yeah. I want to stay in thirds.
Mhm.
So what if I asked you about 1/3 of 3/4?
I don't like it. What
One,
why would you want that?
I don't know, 1/3 of 3 anythings?
Yeah.
Wait, what do you mean? Yeah.
1/3 of 3 anythings?
Yeah, what's 1/3 of 3? So this is fourths,
Yeah.
1/3 of 3/4, but what if it was 1/3 of 3/5 or 1/3 of 3/7 or 1/3 of 3/11?
Yeah. So then it'll just be a fourth.
So 1/3 of 3 things, 1/3 of 3/4 would be
Yeah.
1/4, and then
Mhm.
2/3,
It's 2/4.
2/4. So in this case, you actually stayed in thirds.
Mhm.
Once I forced you
Mhm.
to. So when I said 3/4 of 2/5, you were like, I'm going to percents and decimals. But we could think about 2/3 of 3/4. You flipped it around. I was like, well, I think I could think about 3/4 of 2. That's a
You know
fine
why
way.
I think I did? I think because we were just talking about 75,
Yeah, and when
which
I
is
asked you about a third of 75, that didn't flow,
Mhm.
at least as well.
Yeah.
Does it flow better now that we've kind of thought about, like, could you think about 1/3 of 75?
Yeah, I don't think that it's that I can't. I think it's like because we're constantly like remembering and using what we've recently tinkered with.
Totally. Yeah, that's what's pinging in your brain right
Yeah.
then. Yeah.
Yeah.
Yeah, interesting. So I find it interesting that when I deal with thirds, I very rarely, if ever, go to decimals and percents. I
Sure.
almost always stay in fractions and think about 1/3 and then scale it to 2/3.
Mhm.
Um, so that's kind of interesting. Let me give you another example or another question. What if I asked you for 0.5 times 16? What do you think about?
Hang on a second.
Oh, sorry.
I
Yeah.
just realized
Mm.
that I wrote down on my paper 1.75. Somebody's screaming in their car right now. They're like, it's not 3/4. I think it's
Would
why I
you
was
say?
stuck on 75. I said 1.75 because that's what I wrote down. And it's 1.5 thirds. So sorry. I
Oh, I
just
didn't. I didn't even hear that. Okay.
I looked down at my paper and I was like, why does it say 1.75?
So
Stuck
when
on
you
the
said
75.
okay, so what you're saying that 3/4 of 2
Yeah.
is 1.5.
Yeah.
So 3/4 of 2/3 would be 1.5 thirds.
Yeah.
Which then we could scale to get an equivalent. So that'd be 3. Like if I double 1.5, that's 3.
It's still
And if
half,
I
yeah.
double 3, it's 6. Now it's 3 out of 6. Or
Or it's
1.5 out of 3
1.5
is
thirds.
still 1/2.
Yeah.
Right? Okay.
Sorry. Okay, ask your question again.
All right. So the next one for us all to think about.
Yeah.
I hope everybody's hanging on. Hang on, everybody.
Gosh.
So if I were just to ask you a completely non-related problem, 0.5 times 16. Do
Yeah.
you stay in decimals?
I do not.
What do you do?
That's half. In that circumstance, it's fraction 1/2. It's 1/2 of 16.
So instead of thinking about 0.5 times 16 and writing it down and drawing the line and then doing the turtle and the magic zero and all that, well, because you could see that if a kid had not had this, it's decimal multiplication. I know how to do that. I'm going to write these down. But you're saying, no. Like think about 0.5 is 1/2. Oh, it's 1/2 of 16. Yeah. Okay. Mm-hmm. So you can just think about half of 16 is 8. Cool. How about if I asked you 1.5 times 16?
Yeah, that's 1/16 and another half of 16.
And we really want kids to be able to do that, right? We want them to be able to think about 1.5 as 1.5 so that they don't, again, write everything down, do the whole algorithm, butt cheek the decimal at the end. Oh, mm-hmm. Or we could just think about 1.5. How do you think about 1.5 16s? What is that?
I think about 1/16, which is 16, and half of 16, which is 8. So that's 24.
So 1.5 times 16 is 24. Cool. What about something like 0.95 times 88 or 95 hundredths times 88? What do you think about?
That is percent to me.
Okay.
So 100% would be 88. And then I'm going to go back 5% because it's so close to 100. So, I like over. Mm-hmm. So I'm probably going to think 10% is 8.8. 8 and 8/10. Mm-hmm. And then 5% would be. See, I'm saying point specifically because it's. I want people to. I'm
not picture fractions.
Decimal. Yeah. So 5% would be 4.4. Mm-hmm. So then I'm going to go 88 minus 4.4.
So 100% minus that 5%. And what is 88 minus 4.4?
88 minus 4 is 84. So 83.6.
Cool. So you're thinking about 0.95, and I could have said 95 hundredths, but we're trying to give everybody a vision of what a vision.
Man, a
visual is what I'm trying to give everybody. What?
I would be so unhappy to do an algorithm for that, like to write down 88 times.
What would kids do, right? If it's 0.95 times 88, they'd probably write the 0.95 on the top and then 88 underneath that, and then they would do a ton of multiplications and then butt cheek the decimal.
Yeah.
Or we can help kids realize the equivalencies involved and do this code switching thing. Like, how do you want to think about what's happening here? And then use the interpretation of these rational numbers that fits the situation best. And maybe even compare, how kids are thinking about it. Cool.
Yeah.
How about, are you ready for one more?
I feel like I'm having a test right now.
All right. What about 120% of 5? Because I could algorithm this, right? I could say, let's see, I'm supposed to turn that percent into a decimal. And then I could again do the long multiplication and butt cheek at the end.
Yeah.
But how are you thinking about 120% of 5?
I like that it's 5. Because I'm going to say 100% is 5. And then when 20%, I think I could do with percents, but I also could think about it in terms of fractions. So 20% is a fifth. So a fifth of 5 is 1.
Oh, nice.
So then that would be 6.
So 5 plus 1.
Answer.
So you did 100% plus 20%.
Well, I did a fifth. So I did 100% and a fifth of 5.
A fifth of 5. Sure enough. All right, cool. I like it.
Yeah.
So there's this idea of code switching that's highly involved in working with rational numbers, fractions, decimals, percents. Yeah.
Yeah. And I think what's important to consider here is that when, I think often we say, okay, I'm in the decimal unit as an extension of maybe some whole numbers. And then in some other point of the year, I'm going to talk about fractions. And then as kids get older, we're going to talk about percents. And there's such value.
Can I pause you for just a second? In that, what was the first one you said? Decimal
Decimals.
unit? In the decimal unit, we might actually say, how do I turn this into a fraction, and give kids kind of a procedure for
Uh-huh.
doing that.
Uh-huh.
And then when we get into fractions, we could say, so how do you turn this fraction into a decimal? And we could give them another procedure to do that.
Uh-huh.
Or here's an alternative. Instead of doing that, what if we did more equivalence to start with? Less
Right.
procedures and more equivalence, and then engage them in the types of tasks that we're just doing, and
Yeah.
ask kids to, like, how could you use what you are reasoning about fractions and decimals and percents to do this code switching? So sorry, can you remember what you were?
Yeah, I think, I do think that there are teachers who are trying to make a connection between problems. So I've
Of
seen,
course.
somebody just sent me a worksheet that's like, you know, uh, hey, I'm going to give it to you in fractions. You write the decimal or the percent equivalent. And I think people sometimes try to connect that they're equivalent,
Mhm.
but not in the way that we were just describing. Like actually using what you know in a way that is meaningful and that you see the value of flowing between. And I do think that there are certain times where I gravitate towards percent or I gravitate towards decimals or fractions. There's some general ideas that I've come to generalize about when I don't want one form or another. And I think you develop that through experiences over and over again. I mean, we could make a list and say, you don't want decimals for these fractions, but that's meaningless. It doesn't really
It's
help
another thing to
anybody.
memorize.
Yeah. I think flowing back and forth between decimals and percents is really nice. I think it's they're maybe a bit easier, but sometimes the fractions are super nice and sometimes not at all. Like the third that we were just talking about.
Yeah, like if I'm dealing in, if there's a problem and there's something with 1/3 or 2/3, I'm rarely, if ever, going to think about decimals or percents. I'm
Yeah.
almost always going to think about divided by 3.
Yeah.
Like 1/3 to me is going to like symbolize divided by 3. But if I'm
Yeah.
dealing with fourths or fifths, or I might think about 25%. I might think about 20%.
Uh-huh.
Well, I might even think about decimals if I'm finding the fraction of that decimal. Like in other words, if it's the sort of second thing I'm thinking about, because I might think about like you did earlier, 0.4.
Mm-hmm.
Like I could think about 40%, but I could also think about 40 cents and then find chunks of that.
Yeah.
So there are definitely times where um, thirds, sixths, ninths, those are all almost always going to stay in fractions for me. That,
Yeah.
like, very rarely, if ever, are they going to turn it into. Is that true for you?
Yeah, I think so, except when I just want a general like estimate, which I think there are
Mm,
times in life, maybe not on a classroom worksheet, but in life, 33% is good enough.
mm.
Um, yeah,
As lo-
so
And you'll just realize whatever you just estimated is going to be a little less because it should have been
yeah,
33.3333333%.
yeah,
Yeah. Okay,
yeah.
cool.
I think what's important to know is that the more experience that you have and you create kind of this comfortable, like natural ability to go back and forth, the more that you will use it. So I remember quite some time ago, you were like, man, why do you do that? Why do you kind of go back and forth? Or how do you decide when? And you do it all the time now because it's a thing. And I think once adults become aware that it's a thing to do, then the more they do it, the more I would encourage people to give it a try. Like when you see a form that you're like, I don't know, what do I know about this? Stop for a second and think about, do I know the fractional equivalent? Do I know the decimal equivalent? Do I know the percent?
And then see what pings for
Yeah.
you at that point.
Yeah.
Yeah. And I think one of the maybe the most important things we want to bring out in this episode is, rather than the worksheet you mentioned earlier, where it is, if I give you this form, give me the other form, we're
Hmm.
suggesting let's actually solve problems
Yeah.
and suggest. So we could do problem strings that kind of suggest, hey, here's one form. How about this form? How about
Uh-huh.
that one? Now let's compare.
Uh-huh.
Maybe we'll do that in a future episode where we actually do a string like that.
Uh-huh.
To end this episode, I want to end with just maybe one more example.
Okay.
What if I were to give you the problem 76 times 36? Now,
Okay.
off the cuff, just kind of naked, you would
Uh-huh.
look at that maybe and say, it's whole number multiplication. You're going to do some whole number multiplication strategy. But I'm kind of curious. What do you think about when I say, you're chuckling, 76 times 36? Well, maybe listeners,
Yeah, I was gonna say let them
what
solve.
comes to mind? Like if
Yeah.
if I say 76 and 36, are there
Mhm.
some other forms of rational numbers that are pinging for you right now? And if there's not, that's okay. We'll let's travel the path and see if we can make that path a more well-traveled path.
Yeah.
All right, Kim, what are you thinking about?
Okay. I'm going to think about 75% of 36.
Okay.
And I know that 75% of 36 is 27. So 25% is 9. So scale up, 75% would be 27.
And I might have to say 25% of 36 is 9 because a fourth of 36 is 9. My brain might have to go there. Okay.
So once you know that 75% of 36 is 27, you can scale up to say, then I know 75 times 36 is 2,700, because you're going to scale up by 100 to get from 75% to 75.
Mm-hmm.
So now we're at 2,700.
And that's 75 times 36.
Yeah. So you just need one more 36
to get 76 times 36.
So that's 2736.
Bam. Which is one of my favorite problems ever.
Is it really?
It is. It is.
Okay.
I think we told a story once on the podcast that Craig came home, my third son came home, and his teacher had said, no more baby strategies. You guys are going to have to learn the multiplication algorithm and hand drawn. I don't blame this teacher, by the way. I blame the district because they hadn't trained her. And it was a hand-drawn worksheet with problems that you don't use your baby strategies because you'll be too inefficient. Mm-hmm. And the first problem was 76 times 36. And I literally said to my then 6th grade son, I said, hey, Craig, when you hear 76, what do you think about? And he said 75, 3/4. So he didn't go percent. He went to fractions. Yeah. Okay. Right. He's like 3/4. And I was like, do you know 3/4 of 36? And he's like, well, I can 1/4. And then he scaled it up to get 3/4. And I was like, okay, so then can that help you with 70? Exactly what you did. Yeah. Can that help you with 75? He's like, okay, you just scale that. And I was like, okay, here's the hard part. Once you know 75 times 36 is 2,700, but you need 76 36s. He looked at me and he was like, are you kidding me? And I was like, why are you mad right now? Craig, who never gets mad. Yeah. Craig is one of the most even-keeled, low-key, just doesn't get riled. He was hot. And he goes, baby strategies? She's trying to tell us not to use baby strategies, but to use the algorithm. And this is the particular teacher that had drawn the turtle over the whole numbers to help the kids know what. And then when the magic zero, she said the turtle lays an egg. And he's like, baby strategies? We could have been learning all year long. We've been memorizing stuff about decimals, percents, and fractions. Yeah. We could have been doing problems like this, getting better at multiplication. And now I would give him these words and code switching. Yeah. Yeah. So it was a very meaningful moment for me to go, you had already, I had already been doing some code switching at that point, but now I knew we could do it purposely with kids. Yeah. Wow. Yeah. We could do it purposely with kids. All right, Kim, that was fun. Thanks. Yeah. All right. Thanks for tuning in, everybody, and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. And thanks for spreading the word that math is figureoutable. Don't forget, y'all, go to mathisfigureoutable.com/PS book launch. That's mathisfigureoutable.com/PS book launch to register for the free Problem String Book launch webinar taking place on June 19th. That's mathisfigureoutable.com/PS, like Problem String Book launch. See you there.